Hello, welcome to our Kubeflow demo session. The goal of this session is to demonstrate how a typical banking use case can be tackled by Kubeflow. We're going to build a credit scoring model, then turn this model into a web application, and finally operate it in real time. All right, we start in the landing page of Kubeflow. Note that on the left-hand side, there are several Kubeflow modules. And the first one we are going to use is notebook servers. From the technical perspective, notebook server is a Docker container running Jupyter Lab. And from the functional perspective, it is a place where data scientists develop scripts and models, and they can also explore data there. As you can see, right now there is already one notebook server running for me. But if I would like to start a new one, I would simply click here and go through this notebook startup wizard. So I would give my notebook a name. Let's call it the test book. I would select a Docker container from which I want to spin it up. I can specify how many cores I want and the size of a RAM. And if needed, I could also specify the graphical card. But I will not do it now. And then I just launch the notebook. After a few minutes, the notebook will be up and running. Okay, so now we have the notebook servers ready. So let's jump to the fun stuff. I will connect to one of my notebook servers. That will redirect me into the Jupyter Lab landing page. In this demo, we will mimic the whole end-to-end modeling process. So the first thing to do is to develop the credit scoring model itself. The modeling part, or machine learning part, if you wish, is composed from two subparts. The first is that we create a notebook for exploratory data analysis and model prototyping. And later, when the model prototype is ready, we will package it into a training pipeline and show how a training pipeline can be used for experimenting. So the modeling notebook is something that all modelers and data scientists are familiar with. The goal is basically to get to know the data and develop some first modeling scripts. The actual modeling in this notebook is simplified because modeling itself is not the goal of this demo, but I believe that it still reflects what you would normally do in real life. So you would start with installing some packages and then downloading data from your sources. Since we are working from Python and Python notebooks, we are not limited to any specific type of database. So anything where you have a Python connector to, you can use. In this particular example, I'm using Elasticsearch. So as you can see, I downloaded the data and I did some very limited data wrangling to end up with my base table. And then I can run a couple of typical credit risk modeling steps to arrive at logistic regression. And finally, I turn the logistic regression into a scorecard. And when I'm done with my logistic regression, then I can look at the performance. We see ROC about 0.8, not so bad. So I would stop the modeling here. The last thing that I would like to also show is that if you would like to share this notebook with someone who doesn't have an access to an environment, you can always export it to HTML or PDF. The exported notebook will appear here, and then you can just download it and send it to whoever you might want to send it to. So to summarize what we've seen so far, we've created a notebook server with desired computational resources. We've connected it via web browser. Inside of that notebook server, we created a modeling notebook in which we explored the data and developed first prototype scripts. And directly from this modeling notebook, we created an HTML documentation that we can archive, for instance. Now, in the next step, I'm going to show how this modeling notebook can be turned into a training pipeline and how this training pipeline in turn can be used for experimenting. All right, so let me now open my training pipeline notebook. Unlike the modeling notebooks that are pretty much without a structure, pipelines impose a certain structure into your work. This structure becomes handy when you want to run the same workflow over and over again, changing just few parameters. For instance, training of a predictive model is a great use case for such pipelines, but there are also other use cases where you can use pipelines. Conceptually speaking, each pipeline is composed from pipeline steps, as you can see here. And each step of this Kubeflow pipeline is defined using a Kubeflow pipeline meta language called KFP. For each step, you need to define two things. The first is the pipeline function itself. The pipeline function, as you can see here, basically encapsulates the business logic. So in this particular example, this is just a copy paste of the script from your modeling notebook. You can see that from here onwards, it's the same thing as we've seen in the previous notebook. And the second thing you need to define is the pipeline function operator, which is here. The pipeline function operator defines where the function will be executed. So it basically tells Kubeflow in which Docker image it should execute the function that you defined above. So you can see here that the function is defined here, and here you tells Kubeflow which Docker image it should use. So like this, you can define the individual steps. In the previous, hereby we defined the training preparation. Here we do the training itself. Again, the function basically just encapsulates the logic as I explained. And that's the very same logic that we've seen in the modeling notebook. And then again, we have the pipeline function operator. And we can go like this and define as many pipeline steps as we want. Finally, once all the pipeline steps are defined, you can define the pipeline itself, which means basically defining the ordering, the dependencies between the steps, and the parameters that you want to define in the pipeline. So again, the pipeline is defined using the domain-specific language of Kubeflow, this DSL. Here, using a simple Python function, you define what are the parameters in the pipeline, and here in the body of the function, you define how the steps of the pipeline are ordered and chained. You could probably notice that what I said before, that the pipeline function is basically copy-paste of the modeling notebook is not exactly true, because except for the business logic itself, which for instance is here, so this is really the copy-paste. There is also additional few lines of a code, and these are this is a code that helps you to store metadata of the pipeline, and we're going to show later why these metadata are important and how we can use them. Okay, but so far my explanation was quite technical and maybe a bit theoretical too. So let me now show you what are the practical reasons to invest time into specifying these pipelines. Once the pipeline is defined in a notebook like this, you can create a pipeline run directly from this notebook. And you do it just by executing this one-liner where you point it to the pipeline that you specified, as here. And you can also specify arguments that you want to, that's the parameters that you would like the pipeline to use. I am not specifying any because I specified here some default parameters. That is the reason. So now I execute the pipeline, I run it from the notebook, and you can see that Kubeflow offers me a link to the run and to the experiment. I will talk about experiments in a bit, so now let me show you what a run is. When you follow the link, you will be redirected to the Kubeflow UI, where you can follow up on what is happening in the pipeline. You can click on each step and explore a couple of things about the pipeline. I will also show these a bit more detail in a bit. But this step of running pipeline directly from Notebook, I use it typically to test that my pipeline is working fine. Now, as you can see, everything run till the end, so I know that the pipeline, as I specified in my notebook, is okay. So now that I know my pipeline is specified well, I can export it as a code, namely as a YAML file, for which I use another one-liner provided by Kubeflow DSL. As you can see, the YAML appears here. The YAML file is quite handy when it comes to versioning pipelines as a code. Another handy feature that is offered by the Kubeflow client is uploading of a pipeline from script directly to Kubeflow's UI. It's again a one-liner that I execute, and he will tell me that the pipeline was uploaded, and then I can navigate to the main page of the Kubeflow. But now we will go not into the notebook servers as before, but into pipelines. And there I will see my pipeline uploaded. Okay, so when my pipeline is uploaded to Kubeflow UI, I can start experimenting with it. In order to do that, I need to create an experiment to track my runs. So I'll go to experiments and I will click create a new experiment. I will call the experiment webinar credit risk modeling, for instance. Experiment for training pipeline. Okay, and I can launch first run where I can choose my pipeline. I will use this pipeline. You can give it a name, for instance, run with first set of parameters. I will skip the description. Experiment is filled in. It's going to be one of run, and here are some run parameters that I can define. You can see these are the ones that I predefined in my pipeline definition in the Jupyter app. So these are these. And I can, for instance, I exposed the bucketing structure of the few of the variables or few of the predictors in my credit risk model as a parameter. So for instance, for predictor H, I can change the bucketing structure to 30, 35, 40, and here I can go, for instance, 8, or like I can go 5, 10, 20, 30, and I can start my run. And I can see under my experiment, I can start to track different runs. For instance, I can create a couple more runs with different parameterization. So I again choose the same pipeline. Can call it training 2, for instance. The same thing here. I'm gonna do a different parameters now just to explore. This one I can keep like that. And I can create another one just to have 3 of them. So I again select the same pipeline, 3, and now I will change, for instance, this guy to 10 and 20, and I will start it. And you can see all my different experiments are stashed into this experiment object. I can see the status of my runs, and for those runs that have been executed successfully, I can even see some performance statistics of the model. And indeed, these are coming from the scripts, and these are the metadata that I was talking about. Let me wait a bit for the other runs to finish. All right, so now that all of my experiments have finished, I can explore which pipeline yields the best model just by looking at the overview in the right. I have 2 stats here, the AUC on the test and on the train sample. Note that in the real life, I could run tens or hundreds of these different experiments with different parameterizations in parallel, since underneath Kubeflow there is Kubernetes that scales very nicely. Note also that in some real-life examples, like training deep neural networks, for instance, these training pipelines can take several hours to finish. So you can imagine how convenient this is to run these experiments overnight and in the morning come to this overview and see which parameterization works best. Also know that you can specify all of the metrics that you see here on the right-hand side by yourself. This is not something hard-coded in the UI, for instance. All right, so let's say that after some investigation, I pick model from the first run, so from this pipeline, as the model that I would like to deploy as a real-time app, and I would like to hand it over to the DevOps people. So what I still need to secure is that the coherent set of artifacts is handed over to DevOps. That means that the model and the data that led to estimation of this model are handed over coherently with the script that produced this model. Exactly for this use case, there is another Kubeflow module called the artifact store. And the artifact store is there to store the metadata of your pipeline runs so that you can keep track of which pipeline produced which models and which metrics and which data were used to do this. So the pipeline that produced my winning model is this one. You cannot see it, very well now because the name is too long. This is basically the timestamp. But as you can see, there are three types of artifacts that my pipeline produced. There are metrics, so that's the AUCs and the guineas that I was showing before. Some model-related artifacts and dataset, namely input dataset related artifacts. You can dig deeper, so you can, for instance, open the model artifacts and you will see where the actual model file is stored. This is important later on for DevOps to be able to find back the model from this run. Some creation time for tracking, for instance, what was the model type underlying, what was the project for which we created this model, who is the owner, etc. You even have some simple lineage. So for instance, you can here see that the model is related to the execution that took time at a given time. So in other words, by using the Kubeflow metadata and the artifact store, data scientists can hand over the artifacts to DevOps coherently. All right, so at this point, almost everything has been done on the side of the data scientist or modeler. The modeling script has been built in Jupyter Notebook environment. A number of model specifications have been tested by running multiple automated training pipelines. The best model has been selected and stored, and its location is tracked by Kubeflow metadata. Likewise, the training data that produced this model have been also stored, and their location is tracked by the Kubeflow metadata. The modeling and pipeline scripts are so far stored only in the notebook servers. And since the data and models are tracked by the artifact store and they are stored in a shared storage space, the only thing that remains to be handed over are the scripts themselves. And as you know, the best way to coherently collaborate on the code is to go via Git. So I will now go back to the notebooks. Well, there are actually two ways to go about it in notebooks. Either there is a Git plugin where you can drag and drop and do the commit and push, or a bit faster way is to go via the terminal. So you can just open a terminal and navigate to where your scripts are. So it's like this. And we will just do a commit. Okay, so I will add all changes. And now I can commit. And as a message to the DevOps people, I can put something like, please deploy version or workspace version, and I can just copy this workspace version. And this workspace version basically uniquely defines the input data and the model, as I explained before. So I'll just put it like this. Okay, and so now it's committed, and now I just push. And there we go. So this is basically really the end of the story for the data scientist. All the artifacts are in the artifact stores, and scripts are committed to be deployed. So now the ML DevOps story can start.